Hi ladies, in this video we're going to go through the Exam 1 revision solutions for the trigonometry section of the worksheet. So there's two other videos, one for parabolas and one for probability. So this one we're going to do trigonometry. Okay, so question 10, find the exact value of the pronumerals, oops, how'd that happen, in each of the following diagrams. Okay, so this is where you need to know your exact values. So if I just, oh gosh, very user-friendly. Let's just make you a bit smaller. Okay, just so I can see the triangle at the same time. All right, so the first thing, let's label the triangle. It's a right angle triangle. So here's our hypotenuse, the opposite, and our adjacent. So I'm going to be using the sine ratio. So sine 60 equals opposite over hypotenuse, which is 40. And that means x is equal to 40 times sine 60. Now this is where you need to know your exact values, okay? So we can't leave it as sine 60. And obviously you don't have your calculator. All right, so that's root 3 on 2. And then we just need to simplify that. So the 40 and the 2 cancel out to give 20. So x is equal to 20 root 3. All right, in question B, I might just put a square around that so we can see the final answer. We've got the value of m and we've got n, okay? So we need to work with what we've got. Now, in this triangle, I'm just trying to think, we've got two triangles. This is a right angle as well. Okay, so let's just do this triangle first. So we've got 6 here, this is 45, and this is m. So just labeling the triangle. So there's our hypotenuse, opposite, and adjacent. So we're going to be using the tan ratio. So tan 45 is equal to opposite, which is 6 over adjacent, which is m. Okay, and switching 6 and tan 45, sorry, m and tan 45 over. Now tan 45 is 1, so the value of m is 6. Now when you think about it, we didn't have to really do the calculation there because this being 45 degrees here means this is also 45. And making it an isosceles triangle. So m is going to be the same as this side, which is 6. Okay, but there's the working out if you didn't know that. Okay, let's do the other triangle. Probably shouldn't have drawn it so big because we need some working out space. All right, so we've got 60 degrees here. Here's n. M is 6. So again, we're going to be using tan. I'm just going to label that. So this is O, this is A. So tan theta equals opposite over adjacent. So tan 60. Opposite side is 6, adjacent is n. So n is equal to 6 over tan 60, okay, which is root 3. And we shouldn't leave a third in the denominator, so let's just rationalize the denominator. So it's going to be 6 root 3 over 3, which is equal to 2 root 3. And put a little square around that. So not much working out space there. All right, so knowing your exact values is helpful in this situation. And you will come across questions like that. So please make sure you remember your exact values. All right, question 11. All right, so a bearings question, which students never really like, and there's no diagram here. So let's get this diagram drawn. So Jenny hikes 6 kilometers on a bearing of 132 degrees. from campsite A to a waterfall. All right, so let's just draw bearings first. So we've got north up there. So we're going to be going 130 degrees. So remember, north is at 0, east is 90, south is 180, and then west is 270. So we're going 132 degrees. So we're going down in this direction. So I'm going to redraw it just over here. And that's 6 kilometers. All right, from campsite A to a waterfall. Click an A. Oh gosh, let's just rub it out and start again. Okay, Jenny then continues to hike for another 10 kilometers on a bearing of 75 degrees. So 75 degrees is that way. So we're going to keep going in that direction. It's a little bit longer, so 10 to campsite B. All right, so we need to clearly draw a clearly labeled diagram. So I'm going to have to put my bearings in. Okay, so remember your bearings always go from north. So this bearing here is 132. And this bearing here is 75. Okay, so there's a good enough diagram. Find the true bearing of the waterfall from campsite B. All right, so I might just do this in a different color. Let's do some green. Now, this is where it's tricky. If I'm not drawing the diagram correctly, it can make it a bit weird looking, but we'll just do it anyway. So there's the green line. So we want, oh, no. That's not what we want. Is it? We want the true bearing of the waterfall from campsite B. Is there more to that question? Is that it? Okay. Because the first part of the question was kind of useless. All right, so let's put our north in. All right, and let's do the bearing we want. So remember, your bearing always goes from north, and we go all the way around here. Okay, so we've got 2 parallel lines. We've got a line that transverses them. And this angle here is 75, which means this angle here is also 75. Now, if we're doing the bearing, remember your bearing, doing too many colors here, goes all the way around. So the bearing is going to be 180 plus 75, which is equal to 255 degrees. Just making sure I've drawn that correctly. Okay. Question 12. A boat has overturned in the ocean 3.4 kilometers from the base of a cliff. Okay, so let's draw the cliff. 280. Now we've got different units. We've got kilometers and we've got meters, which is always horrible. But let's convert everything. It doesn't say meters or kilometers in our question, so let's just convert everything to meters. So 3,400 meters. And here is the boat. Okay. The pilot of a rescue helicopter, which is directly above the cliff face, can see the overturned boat. Okay, so here's the helicopter. And it can see the boat. And the angle of depression, remember, always goes from the horizontal. So that angle there is 60 degrees. Okay, so that's the cliff top. Remember, helicopters are in the sky. So a lot of you, when you were doing this question the other day, didn't draw that part properly. Now, question B, what we want to know is this distance here. Whoops. Whoa, what am I doing? Sorry. I think I just accidentally pressed the button on my pen. Okay, so we want to know this distance here for part B. So I'm going to call that x. Now, just redrawing that larger triangle. Okay, so that's 60. This is 3,400. And let's call this y. Okay, so y is going to help us calculate x. All right, so we're going to be using tan. Usually in angles of elevation and depression questions, they're more often than not tan, but not always. So tan 60 equals opposite is y, adjacent is 3,400. So again, you're going to need to know your exact value. So y equals 3,400 times tan 60. And we did that in a previous question. I think it was root 3, is that right? Yeah, square root of 3. So x is equal to 3,400 root 3 minus 280 meters. So you can't really change this. Okay, don't go doing 3,400 minus 280 because you're effectively multiplying the root 3 there. So just leave it as 3,400 root 3 minus 280. I feel like I may have made an error there somewhere, so I'm just double checking. Okay. All right. Question 13. Calculate the value of x in the following diagrams. So right angle triangles, similar to the ones we did before, so let's just label them. Okay, so this one we're going to be using sine. So sine 30. Opposite is x, hypotenuse is 63. Sine 30 is a half, but let's just do x sine 30. So half of 63 is 31.5 centimetres. All right, in question B, similar to before, let's just work out what we've got here. So I'm going to label this as y. It's also a right angle triangle. Let's find y and then we can find x. Okay, so we're going to be using tan theta equals opposite over adjacent. So tan 30, opposite is y 24. So y equals 24 tan 30. No, so tan 30 is root 3 on 3, which is going to then make that 8 root 3. So now going back to that other triangle, eight root 3. So now we've got, sine again. We've got no cos. All right, so sine 60 equals, oh my gosh, I'm going blank. Sometimes it's easier to use cos because cos of 30 is a half, but that's all right. Let's stick with what we've got. Opposite is 8 root 3 over x. So x equals 8 root 3 over sine 60. So sine 60 is root 3 on 2. So that's x equals 8 root 3 divided by root 3 on 2. Okay, so when you're dividing by a fraction, you keep your first number, multiply, and then flip. So when we do that, the root 3's are actually cancelling out, and then we're left with 8 times 2 gives us 16, which is kind of nice, isn't it? Okay, so there's our final answer. Little working out. It's worth 4 marks, girls. In your exams, there's not going to be so many marks allocated to a question. Okay, question 14. Sketch the graphs of y equals 3 sine 2x and state the amplitude and the period. All right, so your amplitude is always your coefficient of sine or cos. So the amplitude is 3. And your value of n, which is the coefficient of x, so the period is equal to 2 pi on n, which is 2 pi on 2, which is equal to pi. Now, when sketching your sine and cosine graphs, plot the information first. So our amplitude is 3, so that means the highest value we've got is 3, and the minimum value is -3. The period is pi. So if we're just doing one full revolution of the circle, we're going to pi. Okay, that's what it means by a period. And we split it into 4. So you can see here it's already been divided into 4 for you. To work out that scale, you can just do pi divided by 4, which is pi on 4. So we're going up by pi on 4 each time. So 2 pi on 4 and 3 pi on 4. Now you could simplify the 2 pi on 4 to pi on 2 if you like. All right, so our sine graph always starts at 0. Okay, and then reaches its maximum here, goes down, and its minimum. Now I said it always. Now you're gonna have transformations. Probably going to see them next year in year 11. Okay, but that's the easiest way to draw your sine graph. Now, I was chatting to someone the other day. As long as you can do that basic graph, you're fine now for majority of sine and cosine graphs. So next year, you're looking at moving your graph up, down, left, right. But as long as you understand the amplitude and period, you draw your basic graph, and then you either shift it up or down, left or right. Okay. Now, that was worth 5 marks. It's a lot of marks, isn't it? Okay. Now this one here, same thing, identify your amplitude. So your amplitude isn't -2, it's just 2. Okay, so the negative just means it's been flipped or reflected along the x-axis. So your amplitude is still 2. Your value of n, the coefficient of x over 2, which is 1/2. So your period is equal to 2 pi on 1/2. Now 2 pi divided by 1/2 is the same as 2 pi times 2 on 1. So it's going to be 4 pi. All right, so your amplitude, we're going up to 2, down to -2, and period ends at 4 pi. So your scale, just do 4 pi divided by 4. So we're going by pi each time. Nice easy one. Okay, now your cosine graph always starts at whatever the amplitude is, which is 2. But this time, because we've got a -2, it's just been flipped. So it's going to start at -2. Still crosses at pi. Instead of having its minimum at 2 pi, it now has its maximum. Okay, so you know your basic cos graph. So this has just been flipped. Okay, it's been turned upside down, just like when we did parabolas and you had a negative. Okay, so there's your cosine graph. All right, and I think that's the last question, which is good. All right, bye girls.